Hello students, welcome to All Force e-learning channel. This is K. Nageshwar Rao, your physics faculty. Today we are in session number 36. In the last session we have discussed about wooden plank bullet model. We have explored various possibilities. In fact, don't look at it as a model. Each and every case, whatever case, 4 cases we have discussed, those 4 cases are like 4 problems, 4 questions, 4 numerical questions. Uh, what was discussed? We have taken a pile of planks. Let us just recollect once. We have taken a pile of planks. Each plank's thickness was x. So we have looked for number of planks required to stop the bullet, isn't it? If a bullet is entering with a velocity u and after penetrating through the first plank, if it loses if its velocity reduces by 1 by nth, then number of planks required are this one. What is this? M equal to n square by 2n minus 1, isn't it? And this is the picture. See here, isn't it? So after penetrating through the first plank, its velocity is getting reduced by 1 by nth of initial velocity, isn't it? And the next situation that we have dealt with is, what happens if the bullet's velocity reduces to 1 by nth after penetrating through a single plank? If that is the situation, how many planks are required to stop the bullet? And what is the equation? This is the equation. What is this equation? M is equal to n square by n square minus 1, isn't it? And this is the picture. See, and if if you have taken a wooden block, let us say, and in that wooden block, when the bullet is penetrating, after penetrating through a distance equal to x, if its velocity is reduced by 1 by nth, further how much distance it has to travel to come to rest position? This case was also discussed yesterday. And what was the equation in that case? If it has traveled a distance x, so then its velocity is reduced by 1 by nth, and further we have assumed that it has to travel a distance equal to y to come to rest position. If that is the situation, what is the equation for further distance that it has to travel? This is the equation. What is this? Y is equal to x into n minus 1 whole square by 2n minus 1, isn't it? And this is the picture. See, and if after penetrating through a distance equal to x, if its velocity becomes, or if its velocity reduced to 1 by nth, then further it has to travel a distance equal to y equal to x by n square minus 1. This is the equation and this is the picture. Okay. So these are the details that we have explored in the last class, and now let us continue with a few problems. Okay, students. So look at this question. What is this? A bullet traveling horizontally loses 1 by 20th of its velocity while penetrating a wooden plank. Then the number of such planks required to stop the bullet is. This is a very basic problem, very simple problem connected with this bullet plank model. Remember children, all that you should mind about is this term. It was said that it loses velocity. How much? 1 by 20th of its velocity is lost. Okay. If at all, if it was said that in the question its velocity reduces to 1 by 20th, then the situation will be different. If it loses velocity by 1 by 20th, then it will be different, isn't it? So in this situation, number of planks required will be written as m is equal to n square by 2n minus 1. Okay. If at all, if the situation is like a bullet is traveling horizontally and its velocity reduces to 1 by 20th of its initial value, then the equation will be what? M is equal to n square by n square minus 1. This is what equation you have to use. Okay. But in the current situation, this is what you have to go with. So n is what? N is equal to 20, isn't it? This is what number of planks required when the bullet loses its velocity by 1 by nth. Here it is 1 by 20th. So in place of n, what do we have? We have 20. So just replace it here. What you will get? M is equal to 20 square by 2 into 20, 40, 40 minus 1, 400 by 39, 400 by 39, and which is equal to approximately 10.2. 10.2. Approximately how much is that? 10.2. 10.2 in the sense, is it like number of planks required 10.2? 0.2 plank, it doesn't exist. After 10th plank, it is coming to rest position in 11th plank, isn't it? But through the 11th plank, it has not gone completely to the other side. So it got embedded, it got penetrated slightly into 11th plank, and it has come to rest position. That is how you have to understand the situation. Therefore, number of planks required equal to 11. 10.2 in the sense I am not rounding off here. This is not about rounding off. It is about identifying number of planks. 10.2 planks in the sense there is 11th plank. So, when you actually arrange the planks, what you are going to do? You are going to arrange planks of same thickness. So, till 11th plank you will make an arrangement, and in the 11th plank bullet comes to rest position. So, if the question is how many planks are required, obviously 11 planks are required, that is the answer. Let us continue with one more question. Now, let us try to solve this question. See, what is this? The engine of a motorcycle can produce a maximum acceleration of 5 meter per second square. Its brakes can produce a maximum retardation 10 meter per second square. The minimum time in which it can cover a distance of 1.5 kilometers is. See children, here the motorcycle can undergo a maximum acceleration of how much? 5 meter per second square. When the braking force is applied, what is going to happen? Its velocity reduces, it undergoes retardation and it comes to rest position eventually, isn't it? So, how much is the retardation, maximum retardation that it can produce? 10 meter per second square. If this is the situation, what was the task given to this motorcycle? It has to cover a distance of 1.5 kilometers in minimum time. See children, here when you go very deep into this question, you can make a lot of analysis. Let us say the motorcycle has undergone acceleration and it started. Okay. So, there are 2 points separated at a distance of 1.5 kilometers. So, now we really do not know, for example, it has started with an acceleration 5 meter per second square, and it is traveling, and after reaching certain time, let us say braking force is applied. Now, it has started undergoing retardation. Maybe we do not know, before reaching the final point it will come to rest position. It may happen like that, isn't it? Or let us say in one attempt the motorcycle has come to rest position before reaching the final point. Final point is at a distance of 1.5 kilometer. Okay. Now, after that in the second attempt, let us say the motorcycle is accelerated, and when compared to previous case, let us say very early, instead of applying a retardation force, or instead of setting motorcycle into retardation very early, he continued with the acceleration little more, and after some time the braking force is applied. So, now the motorcycle started undergoing retardation, and now it may happen like the motorcycle will come to rest position beyond 1.5 kilometer. So, now here the tricky thing is you have to maintain acceleration and retardation such that finally at a distance of 1.5 kilometer it has to come to rest position. So, in what minimum time this task is possible? In what minimum time this task is possible? That is what you have to find out. Okay. So, let us see solution. I'll consider that there are 2 points here, A and B, which are separated by a distance equal to 1.5 kilometers, or here readings acceleration is given in meter per second square, right? So, I'll convert this into meters, 1500 meters. Okay. Up to this point, let us say it has I'll consider this distance as S1. Let us say it has maintained acceleration A1, and let us say it has taken a time equal to T1. I hope you are able to follow. So, from point A to C, I will call this point as C. From point A to C, how much is the distance it has covered? S1 distance. With what acceleration it has travelled? A1 acceleration. And how much time it has taken? T1. And beyond point C, let us say it started undergoing retardation. Motorcycle started undergoing retardation. Let this distance is what? S2. I will take this distance as S2. Let the retardation be A2. Retardation is equal to A2. Let the time taken in the second slot, I will take it as T2. Okay. So, here what we have to find out? We have to find out T1 plus T2, because I am assuming this T1 plus T2 as minimum. Okay. So, before that, let us consider one more thing. It has started initially from rest position, like we'll take it like that, because the engine of motorcycle, when it starts from rest only. So, u value, initial velocity u is how much? 0. And when it is undergoing acceleration, after reaching this point C, its velocity becomes maximum, and then finally again velocity is how much? 0. isn't it? Right. For this slot, I will apply this equation. Which equation? V square minus u square is equal to 2as. Okay, I will make use of this equation. What is final velocity in the first slot? V. So v square minus initial velocity 0 is equal to 2. Acceleration is a1, distance is s1. That's how we have assumed. So we can write this as v square equal to 2a1 s1. Okay. Now for the second slot, if I apply the same equation, for the second slot, what is the final velocity? 0. So 0 minus, what is the initial velocity for the second slot? This v is the initial velocity. 0 minus v square equal to 2 into, in the second slot it is undergoing retardation. So you have to replace acceleration with minus, and what is that retardation? A2. So A2 into how much is the distance covered? S2. Minus minus gets cancelled, you will have v square equal to 2a2 s2. Compare these two equations, both are same, isn't it? So from this equation I will write s1 as v square by 2a1, and from here I will write s2 as v square by 2a2. That's how you can write, isn't it? Now let me add these two distances. What I should get? I should get 1500 kilometers, right? Therefore s1 plus s2 is equal to v square by 2a1 plus v square by 2a2, which is equal to how much? 1500 meters. Okay. Now a1, a2 both are given. So let us make substitution here. I will take out v square common, and I will take out 2 as well, v square by 2. 1 by a1 is how much? 5 plus 1 by, and that's 10, is equal to 1500, isn't it? And when you go with further calculation, what you will get here? You will get LCM is 10, so 2 plus 1, 3 by 10. So v square by 2 into how much you will get? 3 by 10 is equal to 1500, isn't it? So when you make further calculations, v square is equal to what you will get here, 3 5s are, isn't it? And 2 5s are 10, 0 0 0. So finally you will have 10,000. So v is equal to 100 meter per second. So what is the maximum velocity attained by this motorcycle? 100 meter per second, isn't it? So we'll make use of these details to find out the time. See, time is connected with the two equations, s is equal to ut plus half at square, and the other one is v is equal to u plus at. I will go with v is equal to u plus at. Okay, since v is equal to u plus at, for the first slot I will apply this equation. For the first slot, what is the final velocity? V. What is the initial velocity? 0 plus what is the acceleration corresponding to the first slot? First slot in the sense A to C, second slot in the sense C to B. So A1 into corresponding time is defined as T1. So T1. So V is equal to A1 T1. That implies T1 is equal to V by A1. Similarly, T2 can be written as V by A2. V by A2. Okay. So when I add these two things, I will get the required answer. Minimum time, whatever minimum time he is talking about, that time can be obtained. T1 plus T2 is equal to V of 1 by A1 plus 1 by A2. V is how much? It's 100. Just now we have solved for V. 1 by A1, 1 by 5 plus 1 by 10, isn't it? Acceleration is 5 meter per second square. Retardation is how much? 10 meter per second square plus 1 by 10, and here you will get how much? 3 by 10, 30 seconds. So the minimum time in which motorcycle can maintain this acceleration and this retardation and can reach this point B, which is at a distance equal to 1500 meters from the starting point. Okay, so that's how you are supposed to solve. Okay, so let us continue with one more problem. Let us solve this question. What is given? In a car race, car A takes time t less than car B and passes the finishing point with a velocity v more than the velocity with which car B passes the point. Assuming that the cars start from rest and travel with constant accelerations a1 and a2 respectively, the value of v by t is. Here we don't know what this v by t is. Why he is asking for that, we don't know. But somehow we have to write an equation for v by t. Here no, any numbers are given? No. Okay. So obviously the expected Final answer will be in terms of A1, A2 and T, something like that, isn't it? So here he is asking for ratio between V and T. And what was the situation here? Two cars are participating in the race. Let us say this is a starting point. Okay, I'll take it as 1. And this is the finishing point, or I'll define it differently. I'll take it as P and finishing point is Q. So both the cars have started from this starting point and both have started with initial velocity equal to 0. So both car A initial velocity is 0, car B initial velocity is 0. And from the question it is clear that car A takes time t less than car B and passes the finishing point with a velocity v more than the velocity with which car B passes. So car A details are connected with car B details. If car B is having a velocity equal to some v1, velocity of car A will be v more than velocity with which car B has moved. So I will assume that velocity with which car B is crossing this point as Vb. Okay. Therefore, velocity of car A will be how much? Vb plus V. Vb plus V, because it was said that it is crossing the finishing point. Car A is crossing the finishing point with a velocity V more than velocity with which car B passes the point. Velocity with which car B passes the point is Vb. So velocity of car A will be what? It was mentioned that it is V more than the velocity with which car B is passing the point. Now the other point is about time. Okay. Car A takes time t less than car B. Let us say time taken by car B, I will take it as TB. I will take it as TB. And time taken by car A will be how much? TB minus T. TB minus T. It was mentioned like that. Car A takes time t less than car B. So time taken by car A will be TB minus T. TB minus T. Let me repeat this data again. It was said that car A takes time t less than car B. Car B, I have assumed that car B has taken a time equal to TB to cross this point Q. I mean to reach from point P to point Q, how much time it has taken? TB. And car A has taken a time t less than car B's time. So time of journey of car A will be how much? TB minus T. Okay, so this is the data we have got. Okay, so I will take time taken by car A as TA, and which is how much? TB minus T. And the final velocity of a car A, I will take it as VA, which is equal to how much? VB plus V, isn't it? And whatever ratio V by T he is asking for, that those terms are present in these equations. Let me shuffle this equation. I can write equation for T. T can be written as TB minus TA, isn't it? And similarly, V can be written as VA minus VB. I'll call this as equation number 1, this as equation number 2. Divide equation number 2 with 1. What you will get? V by T is equal to VA minus VB by TB minus TA. Okay. Now, one more thing. I'll call this as equation number 3. Since V square minus U square is equal to 2AS, this is one of the kinematic equation, right? For car A, what is the equation? Final velocity is how much for car A? I'll take it as VA. That's how it was taken here. It is assumed as VA. So VA square minus initial velocity is 0 for both the cars. It was mentioned very clearly in the question. Both the cars have started from rest. So it's 0. You will have minus 0. I'll ignore that. 2 into what was the acceleration of car A? It is given as A1. And how much is the distance covered by car A? I'll take it as S. In fact, both the cars are covering the same distance, isn't it? Both the cars have started from point P and both are crossing the same point Q. So it means both have covered same distance. Let us take that distance as S. Okay. Similarly, I will write this equation for car B. So VB square is equal to 2A2 into S, isn't it? Now, from these two equations, what we can write for VA? From here, VA can be written as under root 2A1S, and from here Vb can be written as under root 2a2s. So let us substitute Va, Vb values in this equation, and we can write equations for Ta and Tb also. How it can be written? See, S is what? Ut plus half At square. This is the kinematic equation, one of the kinematic equation, isn't it? So now, since both are starting from initial velocity, this term vanishes, you will be replaced with 0. So you can use this equation, S is equal to simply half At square. For car A, distance, how much distance it has covered? S only, so I will take it as S is equal to half into, what is the acceleration of car A? It was mentioned that it's A1, and I have taken time taken by the car A as Ta, so it's equal to Ta square, isn't it? Now from this equation, Ta can be written as under root 2s by A1. Similarly, Tb is equal to under root 2s by A2. Okay, so now we have all required things here. Okay, well, substitute all these things in this equation, so we'll get V by T. That's what he is asking for, isn't it? In fact, 4 options were given, so you have to identify which option is right. Let us first make substitution and then let us simplify. V by T is equal to, therefore, Va can be replaced with what? Under root 2A1s minus Vb can be replaced with what? Under root 2A2s divided by Tb is what? Under root 2s by A2 minus Ta. Ta is what? Under root 2s by A1, isn't it? Now 2s gets cancelled, and in the numerator you are left with under root A1 minus under root A2, and in the denominator 1 by under root A2 minus 1 by under root A1. When you take LCM, what you will get? Under root A1 minus under root A2, and in the denominator root under A1 A2. So here let me simplify, under root A1 minus under root A2 by under root A1 minus under root A2. In the denominator, what do you have? Under root A1 A2. So when you take inverse of this one, this term gets cancelled, and what you are left with finally? V by T is equal to under root A1 A2. So this is our answer. Okay, so that's how you are supposed to handle the situation here. All that you need to do is you have to understand these points. It was very clearly mentioned, car A takes time t less than car B and passes the finishing point with a velocity v more than, t less in the sense Tb minus t is the time taken by car A, v more in the sense Vb plus v is velocity with which car A is crossing the finishing point. Okay, so that's it, children, for today. I'll in the next session we'll discuss about few more problems.